Okay, R3e fractions, and now we're dividing. And as I mentioned in the previous video, if you know how to multiply fractions, and I'm assuming that you all do now, you know how to divide fractions. There's just one step you need to take to change division to multiplication. Okay, let's get started. So, one thing I'm going to do before we even start this is to give you a basic idea in math that will serve you over and over and over, and this idea doesn't just apply to fractions but to many things in math. So the following. Whoa. Changes in math generally come in pairs. That means if you find yourself changing one thing, you're going to be changing something else. Changes come in pairs in general. We've already seen that, so just before we go on to division, let me show you an example of how we've already seen that. Do you remember our old friend 2/3? We said we could change that fraction to get an equivalent fraction by multiplying the top and the bottom by the same number. So let's choose 8 this time. We're going to multiply top and bottom by 8, so we're making a change in the numerator, making a change in the denominator. There is our change in pairs. And when we multiply that out, we get 16 over 24. And again, our original fraction 2/3 is equivalent to 16/24. It just looks different, but it has the same value. Okay, let's get to division of fractions. So, as an example, let me write this down. If we have the fractions 9/12 divided by 5/18. Well, I mentioned before, if you know how to multiply fractions, you know how to divide fractions. Because what we're going to do is we're going to change the division to a multiplication problem. So I say, okay, there's my division. I changed that to multiplication, but I've only made one change. I'm going to have to change something else. So what we're going to change is we're going to change the number that follows that division sign. And to change that, since multiplication is the inverse, okay, let's just get out of that. Since multiplication is the inverse of division, we're looking for the inverse of 5/18. And the inverse of that would be our old friend, the reciprocal of 5/18, which would be 18/5. So now, we know how to do this because we've already learned how to multiply. So I'm going to do it using our best friend, prime factorization. There's 9/12. 18 would be 2 times 3 times 3, and 5, nothing more to be done with him. So my favorite part of this, slash, slash, what else can we cancel? Slash, slash, anything else. Sometimes students have the question, can you cancel this 3 with this 3? Well, no, because you're dividing the top by 3 twice. So that's not a legal thing to do. Anytime you cancel, it has to be top and bottom. So I see there's nothing left to cancel in the top with what's in the bottom. So now we just multiply straight across. We've got 3 times 3 times 3, which would be 27. And in the bottom, 2 times 5, 10. And remember, if you've done all of your cancellation up here before you multiply, you're assured that your answer is in its simplest form. And going back to a previous video too, what kind of fraction is this when the numerator is larger than the denominator? Yeah, remember that? It is the so-called improper, but I cannot say that without also saying there's nothing improper about it. So we like the fraction when it's written like this. There's nothing wrong with it. Okay, let's try two more division problems, and then we will declare ourselves experts in that. The next one, I'm just going to take a whole number and divide by 3/8. Okay, so we've got, let's put it right beneath it. We've got 4. I'm going, but that's not a fraction. No problem. Throw that whole number over 1 and you've got a fraction. So all I did was convert 4 to a fraction. We haven't really changed anything. But we've got a division problem, so that means we're going to change that to multiplication, and you have to make another change to get your changes in pairs. So we're going to change the number that follows it to its reciprocal, which is 8/3. And then let's take a look at that and see what cancels. So I've taken both of these fractions and tore the numbers apart to see what they're made of. Oh, doesn't seem that anything cancels, so you go, okay, nothing to cancel, so you multiply straight across. 2 times 2 times 2 times 2 times 2 would give you 32. 1 times 3, that's an easy one, over 3. And since we couldn't cancel in this step, we know we can't cancel or reduce in this step, and we are done. One more problem, we're going to stick with the whole numbers, but this time we're going to be dividing by a whole number. Let's try 2/9 divided by 3. Okay, anytime that you've got fractions, in order to do the problem, you need everybody as a fraction. So we know that by now. I'm just going to do that in this step. Easy to get a whole number to a fraction by just throwing it over 1. Okay, next step. I'm going to change division to multiplication, and what else has to happen? Yeah, the number behind that division sign has to be inverted to its reciprocal, or 1/3. So now we have 2/9 times 1/3, and we would get 2 times 2 over 3 times 3 times 1, nothing to do there, 3. Oh, we don't get to do our slashing in this one. So we go, okay, if there's nothing to cancel, we just multiply across. In the numerator, we get 2, and in the denominator, we get 27, and we know that that one is finished. Okay, I think I lied to you. I want to do one more problem with division. Let's do one in which it may look a little bit strange to begin with, and it's going to freak us out a little bit, but I'll show you, you already know how to do it. So the problem I'm going to take 2/5 all over, oh my gosh, 10/15. And this looks nasty, fractions within fractions. But remember from a video long time ago, a fraction just means division. So this is the equivalent way of saying 2/5 divided by 10/15. So you're going, okay, I know how to do that. One more time, let's go through this, and I'm going to go a little bit faster, and I'm going to do several things at once. I'm going to change my division to multiplication. I'm going to flip the second fraction, and I think I'll take 2 steps here. 2/5 times, let's see what each of those are made of. 15 is 3 times 5. 10 is 2 times 5. The fun part. What can be canceled? Well, here's a 2 and a 2, a 5, and that 5 can cancel with either of these 5s. It doesn't really make any difference, so we'll just cancel it with this one. And so when all is said and done, nothing left to cancel. What we have left over is 3/5. So look back at this original problem. Looked nasty, didn't it? But you knew how to do this, you knew how to do this, you knew how to do this, and then you knew how to get that final answer. Okay, that's it for division, and I think that's it for R3. I will see you in R4.